So this is a little experiment of some of the IOTT stuff I got going. So this is the one board there that has the ESP32, which is basically here. This is the loconet adapter. This is a buck converter, gives you the voltage you need. Takes the DCC track voltage and gives enough power for these devices to work, the ESP32 and the loconet and that. And then down here is the this is the circuit for the lights, RGB lights, which is connected to this panel here. And as you can see, here is the network connections in and out. So one of the things is if I trigger a loconet, some loconet traffic, let's see, you should see that light, see the blue light there, it starts to trigger. And because I have the gateway set up and the loconet all set up on the Raspberry Pi is running Node Red, and all these things are connected together. I also have my M5 stick here working. Let's see if it can adjust. So that's the loconet viewer. So if I again trigger some traffic, let's see. You see stuff's changing here. So what's happening? The only thing that this guy's getting is he's getting 5 volts power supply on this end. So there's no hat connected, and there's no Grove module. It's just connected through the built-in Wi-Fi connection to my router, which is again connected to the Raspberry Pi, which this guy's giving information. So it's just a different way to show that how this device is sharing, and this guy's listening in on the traffic. He's able to pick up what's going on. Hopefully I'll end up getting a nice, maybe the way the information is displayed properly. There's different ways. Like if you use a JMRI, there's some program, a Python program that displays, it tells you it's a turnout that's being switched. Turnout 38 is being switched such and such a direction, and block such and such is being flipped. So it becomes a more readable, useful information, as opposed to here you just see the hex, I think hex information, hex key information. So that's what I at least wanted to show how this is working together. Thanks.